We have discussed about the concept of Ohm's law. Ohm's law in the sense the potential difference across. I actually also explained the concept of, suppose that I am taking here a conductor you before in the screen you may see right now. I applied the potential difference at one end high potential, at the another end low potential. So obviously at one end the potential will high and this end is the potential low. The electron will start drifting against the low potential right now, and the electron will start drifting from left to right. These electrons are here right now. So we just know here the conductor is made up of atoms. Not only conductor, every material is made up of atoms. Atoms have some electrons, and these electrons together are shared as electrovalency, as a covalency, and forms molecules. Molecules together forms material, and material can be classified as what? Conductor, insulator, is that clear? And semiconductor, is that clear? The middle word is the semiconductor. This is the semiconductor, clear? So our topic of insulator, semiconductor not, our topic is the conductor. So what the conductor actually does, how the conductor behave with it. So conductor have the free electrons right now. So when we apply the potential difference across the conductor, these electrons start drifting here. So as a result they flow from one end to another, is that clear? So how much net charge they constitute? Net charge they constitute, and per unit time the charge is said to be electric current. And the integral of charge with respect to the integral of time, this is said to be instantaneous current. This is said to be instantaneous current. Is that clear, guys? Right now. So Ohm's law we have discussed yesterday. V is equal to IR. What does this mean? Mean that the I is the current, R is the resistance. Resistance depends on the, what we can speak here, nature of the conductor. Means this is the relationship is proportionality, right? And also we know what the resistance is there. So the some relationship you may see here, this, is that clear? So what will here is R is equal to it shall be 2V by I. So if I will here this R is equal to, what can we write? R is equal to V by I. So I is the current and R is the resistance, together is called potential drop. So what do you understand the potential drop means? At this the current, we also can understand I is V by R. So for the constant potential it is inversely proportional to. So resistance is fixed here, so there will be a fixed ratio for any conductor, clear? So here you may see, if I will increase double to voltage, what will the resistance will be double here. Is it possible for flowing the constant current? Obviously no. If I will tends to I by 2 right now, then what will happen? So it shall be I by 2 in the sense that double will be the potential difference of the resistance will. So resistance of a conductor is fixed here right now. So resistance is what? The property of conductor, by virtue of that any conductor opposes the flow of electric current. So you may see here the typical situation is there right now. So resistance is to be discussed here. What the resistance is? I am telling the resistance. So resistances. So everybody know here the resistance R. The symbol for the resistance is zigzag. Is that clear? What the resistance? So we can speak here the property. This is. Go on writing the answer definition. The property of a conductor. By virtue of that a conductor offers what is the obligation? Obligation means what? Obligation in the sense opposition also can be written as opposition to the flow of what? Electric current. This is called the resistance. So simply we can understand, suppose that there is a conductor right now, conductor we made here, and also we have seen the curve. I am showing the curve here right now. The curve is to be before you. the curve I have drawn here, and for the different conductor we have different the curves. For one conductor, for second type conductor, and the third type conductor, different 3 conductors now I am having. Right now it's a conductor A, it's conductor B, it's conductor C. So you may see at the same potential all conductors are passing different amount of current. Why this is happening? Different charge is being passed, we can speak here, right? Different charge is being passed. So why this is happening? At the same time different amount of charge is passing, different amount of current passing. Why this is happening? What is truth? What actually the currents to be passed through the conductor? We can speak here. Suppose this is passing 20 milliampere, this is passing 30 milliampere, and this is passing 40 milliampere. Different amount of current are passing. So which conductor is speaking truth, the 40 and the 30th? Obviously nobody else. Means there could be such a conductor, which can pass more current also. It means they are all conductor are losing some amount of electric current. Electric current in the sense of electric energy. The electric current is actually passage of electric energy from one part to another. Right now it means there is some loss of electric energy when the current pass through the conductor from one place to another. This is called electric energy. Is that clear, guys? Electrical. So the loss of electric energy. So what the conductor do with the electric energy? So it sometimes you might have seen when current pass through conductor, the surface of conductor becomes hot. This is the heating effect of electric current you studied in the 10th class. So the conclusion, the discussion is here where the heat is coming from. The heat is coming from the electric energy. So obviously heat is a form of one form of energy. Electric is another form of energy. So obviously if the all current will pass through the conductor, then there is no loss of, means there is no heat. No heat is there means, but the temperature of surface of conductor will not change. It means that the total energy is being passed. I think, are you getting all the concept? Yeah. Actually the concept is the resistance is the factor that is transforming the electric energy into the other form. Right? The basic concept in physics everybody knows. There is a machine, it's a work. Right now it's what here? Energy, one form of energy. This is the second form of energy. Is that clear? Means by doing work. And the who's doing work? The resistance is actually the offering. The R is actually doing the work here. So what we can speak here, the resistance is the factor that can transform the electric energy into the other form. Right now, so resistance is to be discussed here clearly. So the heating effect of the electric current is actually due to the resistance, and the device which is made for the offering opposition to the current is called resistor. The symbol for resistor is R, and R is non-polar. It does not have any polarity. Is that clear? And the unit, how can we? Yes, its unit SI unit is ohm. So R is equal to, can be written as a V upon I. It could be 1 volt, and this is called 1 ampere. So what will be the resistance for that? The resistance for that can be 1 ohm. Is that clear? So across any conductor, you are taking here a conductor. Across any conductor, if you have applied potential difference of 1 volt, is that clear? And the current passing through conductor is 1 ampere, then you suppose the resistance of the conductor is said to be 1 ohm. Is that clear? So what are resistor? So resistor are the device, and how do we make here? Suppose that day I told you the question. Suppose from a source supply, okay, there is this, from the source supply, it's a 220 volt supply. If any appliances you having appliance, 2 terminals are there. If you connect one terminal here and the other terminal, right now, so your device will work at 220 volt, and you have designed it for working at current. How much current to pass through you have designed it? Suppose 5 ampere current it works on. So what the resistance the device must have? So you can find out the resistance, 220 divided by 5. So 5 2s are 5 4s are 20, and 5 4s are 20, 44 something else, 44 ohm. Means this must have 44 ohm. It means first your current will pass through 44 ohm resistor, and it will make the current of 5 ampere, and then will out pass. This is the actually thing about the resistance. Okay, So resistors can be of different values, 10 ohm, 5 ohm, 16 ohm, different values can be of the resistors here. Okay. So I am telling not only the above special resistance, I am telling the resistance of conducting wire, right? Resistance of conducting wire. Resistance of conducting wire. Resistance of conducting wire. Suppose the wire is at here, the length, wire is actually cylindrical, okay, its length is L, and we apply the potential here, high potential, or here the low potential, clear? So current start flowing from high to low. So obviously inside this what is happening, the electrons flowing through that conductor, clear? So conducting wire resistance we are discussing. So obviously suppose one electron start journey from here, one charge start from journey, actually charge does not move, remember here, electron move from left to right, right to left, okay. So there is electron I am talking about. So these are the electrons here, these electrons are moving, the electrons are moving from right to left. So charge is moving from left to right, charge are moving. Suppose that one charge Q, it's one charge is there, wants to reach at the terminal, it is reaching from P to Q point, it wants to reach from P to Q. Obviously the length is the path here. Suppose that, however, the motion of object is zigzag inside the conductor. This type motion is possessed by conductor right now. But remember, we not have to take this average finally where it started journey from and where it reached to, right? So this we can say here. So resistance of conducting wires. Obviously, if the length will high, so charge will have to travel more distance. It will take much time to reach to the terminal. Then it is said the current passed as a result of passing the charge, clear? So what we can speak here, by increasing the length, if the length will high, the conductor, the charge will have to travel large distance. So what we can speak here, so we can speak here resistance of conductor will increase on increasing the length, let this is right now. If we will increase the length of conductor, the resistance will also increase its value, right? On the other hand, why? Because it will take longer time in the sense charge divided by T is equal to current, right now. If we will increase T, then I will decrease. So time means length increasing, time will increase, current will decrease, and decrease of current is called increase of resistance. So with the increase of length, the resistance increases. On the other hand, similarly, there is another way here. You may see the conductor. The cross section area you may see here from the right side, that is this, its cross section area is there, okay. Suppose that there are charge particles. Charge particle means what? I am talking about charge particles. These are the charge particles, these are the charge particles, and they are just moving rightward direction, okay. So much wider the path, so many charge can pass through at the same time. Is that clear? So larger the area, larger the amount of current. If larger the amount of current, obviously larger the current means increasing the current, decreasing the resistance. So what we can speak here, the resistance of conductor is inversely proportional to area. Is that clear? And a conductor have area and length same time. So combinedly this can be written as resistance R is proportional to length by A, and further can also be solved as R is equal to rho and L by. Obviously again same here, for the same length and same cross sectional area, different material have the different resistance. So when the different resistance they will have, it means obviously this is the property of material. The length is not causing the factor, the materialism of the conductor is causing here. So it is the nature of material. Right now, so what can be understood here? Means the conductor, the factors, these can be factors here. Right now, so our title is factors affecting the resistance. So how many factors are affecting the resistance? First, length. the second area, the third nature of material. Nature of material. And fourth, what is the fourth here? The fourth factor is temperature. So a very primitive question is just here, factors, temperature. So how can it affect here, please guys? So this is a very simple thing. Length L, area A, and nature of materials is the rho here, and temperature T. So you may see the formula here before you. Clear? And further formula can also be transformed like that. A resistance can be written as rho, length is there L, area can be pi r square, where the cross section is circular. In the terms of diameter, it can be written as rho L by pi and d square by 4. Okay, further 4 times rho L by pi d square. So any one formula can be used at a time. Is that clear, guys? So what are the factors affecting the resistance? 4 factors are here. In this case, in the first here, in increasing length, resistance increases, increasing area decreases, is independent, and temperature, increasing temperature, resistance increases. Now question comes here for examination, why this happens, especially about temperature. So you may understand why the temperature increasing causes the increase in resistance. Obviously, increasing temperature means giving heat energy to a substance. So if you will give the energy to a substance as a result of bonding established between the atoms, the more covalent bond will break, or the electrovalent bond break. We can understand here this. An anatomy of the atom you may see. This is the nucleus, center positive nucleus, okay, and the electrons are what we can say. Electrons are, this is the manner that electrons are what we can speak here. Electrons are revolving under. These are the electrons. You may see this electron. The cloud of electrons is there. You may see. Okay, this cloud of electrons is there. So obviously, if the electrons are moving in this way, so what we can speak here? So the electron which are outermost electron means what electron? I am talking this electron, this electron, this electron. They are loosely attached, obviously. So they actually are tied up with the electron of other atom. So these are called the bonding electron. So as a result of increasing the temperature, these electron will get free, and they will so much free that they can move under the electric field. So what will happen when the more electron will? So you will speak, sir, if more electron will flow, the more conductivity will be there, because electrons are constituting charge, and further implies that current. No, in case of conductor, electrons are already in abundance, and a lot of plenty of electrons are flowing here, and the collision is causing the resistance. So the more electron will get free, then more collision rate will be there, and the more obstacle between there. So the electron will take more time to travel. So if the time will increase for the same charge, the distance will increase. So we can speak here, by rising the temperature, more temperature, what? More resistance increases. So please go on writing the effect of temperature. Effect of temperature. This is effect of temperature. Please write effect of temperature. Please write you with the increase in temperature. Go on writing. When we increase the temperature, the electrons from the valence bond get free and comes into conduction band. Conduction band means the electron possessing very less connectivity with the nucleus in conduction band. So on applying the potential difference, the rate of collision increases, and due to increase in the rate of collision, the resistance increases. Right now, have you written this? Okay guys, now effect on this. So what graphical representation will be there? So if we will see the graph means for a resistance of graphical representation for conductor is that you may say this is okay graphical one. This type is a temperature and resistance, is temperature and resistance. This type graph can become here this, but for the what type of graph I am talking about, for here this, clear, for it is for conductor and for semiconductor. What do you understand by semiconductor? Semiconductor have, when we increase the temperature T, the conductivity resistance will decrease. This typical graph will come here. Why? Interesting it is. At 0 means already electrons are less in number in semiconductor. So a rising temperature causes more free of electrons, more freeing of electron, and these free electron gets transient into transfer to the conduction band, and obviously conductivity increases, that the decrease of that. Is that clear, guys? So well understood you about the temperature concerning right now. So now what the factors, first is length, area, and the others. And also study in the 10th class, length increases when the length may double, the area become what, please tell me, half of that, and the resistance become what, please tell me, 2 square time the older distance. This, if you want to know, please write me on my WhatsApp number. This thing you have studied in the 10th class. Is that clear, guys? So this is the concept about that here, right? So further formula can be discussed here, combined formula here, since by Ohm's law here, V is equal to I. So in place of what? In place of R we can write, what we can write? Rho L by A, or also we'll write down here I. Is that clear? So it's a current I per unit area. It's called rho L and A is there. So what we can speak here, this is called what? Density, current density is there. So it's a J, it's a J, rho and L. It's known as the current density, means per unit area how much current is there. This is called current density. Right now, as you must know here, the surface of conductor, the current is available on the surface, not inside the conductor. Everybody know, inside a conductor at a point the electric field is 0. Clear? This is called the skin effect of current. Will remember please. J rho L. So J rho, this is called density. Density further can be written as what here? So potential difference V divided by rho into L is called J, current density. So what will the for unit for current density? The unit can be here volt, and is what here? Density, ohm meter, density about inverse ohm, and meter is there. Clear? Ohm meter, sorry, ohm meter, and length is also as inverse will come here this ohm meter. So what will here this? Volt, okay, volt, inverse, and ohm m inverse. This is that. Clear? Further can be solved this. So this is the density at the, as the, it is saying this is what the density. Further can also be explained here on this basis here. You already have studied the across the conductor, there is conductor. Right now the length of conductor is what? L. So electric field is what here? E into L is equal to V. V for potential difference, as the concept from the previous class. dV by dl is equal to E. Remember this? So where this could be here R. So it can written as electric field into length is equal to what? Here I by A. Also we can write here J, and it's a rho, and it's a L. So here length cancel. Electric field is equal to J into rho. So what will we speak here this? So you may see here this rho is for conductor, fixed it is. So E directly proportional to J, means the current density is directly proportional to the electric field. Stronger the electric field applied, stronger the current density. Right now, so in examination this question comes for sometimes. So you just have to note it. Relationship between current density and, please write a question here. Relationship between, give, or question we are making here. Please write question. This typical questions here. Give a mathematical relationship between, give a relationship between, give relationship between electric field and current density. This typical question comes here, and not the single question comes in exam. This question comes with some question tagged question. Tagged question means some extra numericals comes with that. Clear, guys? Well understood you? So this is the relationship between this. Right? This is called. You may see on your textbook here. So what is that here? It's, you may see here. What is it saying? So this is the row here. Clear? And further can also be further to prove here. Is that clear, guys? Now next is, well understood you, conductivity can also be resistivity, conductivity can also be defined further. Right now, all also we can, another relations we given here is, since rho is the resistivity, the reciprocal of resistivity will be what? Conductivity. It can be given as sigma. So therefore the expression can be written as electric field is equal to, here we will write 1 by sigma, and here will be what? J, or also can be given as J is equal to sigma into E. So what we can speak, conductivity, the current density is proportional to field. Current density proportional to field. Stronger the field, stronger the current density. Clear, guys? Where this is called what? Conductivity of materials is measure reciprocal to that. Clear, guys? Well understood you? Now have note down this expression. So there is two topics I discovered here, discussed, factors affecting the resistance, and here the what relationship between them. And the method of writing solution I am telling you. Please start. Let a conductor, go on writing the method. Let a conductor of length L, is that clear? Electric field of strength intensity E, okay, develops across the conductor. Is that clear? Suppose electrons is possessing every state motion, but it's not possible right now. Potential difference applied across the conductor, developed across the conductor is V, then further is to be discussed here. Clear, guys? Now the next concept is there. So what happens when electric field applies across the conductor? The question is there. What happens when electric field is applied across conductor? What will happen? Across conductor, tell please. So its answer is not only this. Suppose that you are inside a room, okay, and on the surface of the room it is attached with the some we can say some thermal excitation system, and this is a floor here. Is that clear? And you are standing on the floor. Is that clear? Let this is. And if the thermal excitation is done here, the heat is given, and the floor become too hot, then what will happen? You will start vibrating. Same happens in case of that conductor. When you will apply the potential, when you apply the electric field, the conductor electron will start exciting, moving. Since in Dalton's atomic theory, we had studied the electrons continuously in the motion. So moving electron, obviously when the electron is already in the motion, an electric field is also giving the motion. So electric field set them in a specified direction, and they are randomly in motion here. So what will happen? They will have some initial velocity. As we can consider, they are moving on a circular path or oval path. So average velocity can be taken as the initial velocity, 0 can be taken as initial velocity. Is that clear? So actually the field will set them into the accelerated motion. What the field will demand? So what the field will do with the electrons, it will set in the motion. This is called drifting, and the velocity acquired by an electron is called the drift velocity. It means on applying the potential difference across the conductor, the electron start drifting. Okay. So the next concerning is the drift velocity and the origin of resistivity. So please have right guys, drift velocity. Drift velocity. Please move on this. Drift velocity. What do you understand by drift velocity? Same as it may. Please go on writing the minimum velocity. The minimum velocity. Go on writing answer here, please. The minimum velocity. Minimum velocity acquired by electrons on applying electric field. This is called what? This is called drift velocity. So we need to find out the drift velocity. Okay, so we are taking here a conductor. Is that clear guys? The conductor is there, right? And we have applied the electric field. Direction of electric field is there is electron. Suppose electron is the low potential is high potential. It's moving through that here. So what type of velocity? I'm just showing you the microscopical view. You may see how this is happening. So electron travel from this place to this, come back, and finally reach to this point. So it starts journey from P to Q. So this is the zigzag motion of the electrons takes place here. Means different types of velocity is acquiring here, V1, V2, V3 right now, and the direction is changing here. You may see this direction is changing, continuously direction changing. So what we can speak here, this is uniform what? Accelerated motion. Uniform accelerated motion, because we will take this here. So uniform accelerated motion is causing here due to that. So when electric field is, please go on writing, let a conductor of length L, okay, go on writing, conductor of length L, let a conductor of length L is applied across it a field E. Is that clear? The electron charge particle start drifting with a velocity. Okay, since the field is uniform, since the field is uniform, therefore the motion is uniform accelerated motion. V is equal to U initial plus acceleration is to be taken as this. So acceleration is taken as what? A, we can take the acceleration. So A for acceleration, and we will tau. Tau is what here? The T is the tau. Time is there. Okay. So every initial velocity obviously taken as 0. All here. The acceleration is here, A here, and opposite to the direction also is to be taken away for electron. It always move in opposite to the direction of electric field. So will be taken as negative. And tau is what here? It's a time. This is called reluctance time. Suppose that it start in one direction motion. Okay, it change the direction here. So in this is move, drift up, means up to this 2 point, between the 2 point, it will possess a definite motion, and then it will change. So this we can speak here as a time between the two successive collision. You may note down this as note point. It is time between the two successive collision. Time between two successive what? Collision. Successive collision. Clear guys? Is that? So final velocity can be here what? Acceleration into tau. This is what the negative. Here you can write the negativism is due to the direction, opposite direction. But what the field has been given by. So electric field is what here? Obviously force upon charge. Do you know or not? So here the force is what? So we can write down the force is equal to ma. Here m is q, that is called electron E charge, and acceleration is here. Is that clear or not? So force F is equal to ma, electric force. It is called E can be electric force here, and this is mass also, it's acceleration. Clear guys? Well understood you? So what the acceleration is? So here can be written as minus E, and mass is what? Electron here. What the acceleration is? So acceleration will here further we just can write A for acceleration here. The two expressions you may see that here. This is the expression 1, this expression 2 right now. So what? Acceleration can be put here, that so from equation first and second, what is that? Minus E by m is equal to minus A and tau also here. No, yeah, yes, it is correct. So what shall be it is? So acceleration can be given as, or electric field can also be given as, but the drift velocity is before you. Where the drift velocity? This is the drift velocity. We have to give the expression for velocity or the acceleration. What the title is? Drift velocity. The title is drift. So give the expression for drift velocity. So in place of A, what can you put? Yeah, have a look this please. Now further, this is coming as use. So what will be here? This please tell me. Drift velocity Vd is equal to, here is that d minus A, the value will be here minus E divided by m into tau. So E will here plus. So what will it is? E by m into tau. This is the expression for the drift velocity. So tau is fixed here for semiconductor, mass fixed, E fixed, everything else fixed. So what we can speak here? So it can be given as, yes, this where drift velocity directly proportional to field, and this is also directly also proportional to field. Yeah, current density. So actually the current density proportional to field, and drift velocity proportional to field. So we can speak here current density proportional to drift velocity. High the drift velocity, high the current. Is that clear guys? Well understood you? So this can be written further also, and it's fixed here, okay, everything else. But further can also be given expression E is equal to V by L for L. So what can we write here? This expression can be given as a drift velocity E in place of E can be write here V by m into L, and it's a tau also. This is potential difference. So here inductive field further can be written where the electric field is, the relationship between electric field. Where is that? This is electric field. Where electric field? Yeah, this electric field is there. So in place of electric field we can write this. There also electric field is this. Okay, we are just carrying out further electric field. Clear guys? It's what? Potential. So current is to be given here right now. So this is a relationship we can give here. Stop this. It's a relation second. So this typical question comes here. What is the relationship between drift velocity and electric field? Here a title is a relationship between V, D and E. Its answer. Okay. Now second question. Drift velocity can also be associated with the current. What about the current? So current can also, since current is what? Tell please, what is current? Current is charge by time. Okay, what is constituting charge? Electron. Is that clear? So we can speak here, suppose there is a cross section area of conductor. So in per unit this volume, the number of conductor charge conductor is what here? So Q is constituting Ne, is constituted by n number of electrons is going here, and T is the time here. So time can be given further. So constituting is tau time. In tau time, how much current is to be there? Or also further can be written in this. I is equal to what? I can also be taken as a V by R. So in place of V by R, this is Q by T. So we need to find here the current. Tell please, how can we give relationship between them? And we are to find out the relationship between current and drift velocity. Drift velocity is the EV, or also EE by m tau, EE by m tau. There is still a relationship will come here in exam, but we have to find current. So current is equal to Q by time, and charge is what? Electron E charge, n number of electron passing in given time. Is that clear? And every second what the current is? Current passed every second. The tau is there. Further what can be? N electron passing through it. So what next? I is equal to, and here is this Q. So total charge is what here? You may see electron E, net velocity of electron is there. So what can it be there? And I'm telling this, suppose this is a length of conductor, okay, yeah, from here to here n electrons are passing, so they are constituting any charge, n electrons are passing. So what the density of here in per unit volume, n electrons are there. So total conductor current passing over here E null. E null means what? Total charge is there. Q is equal to E null. E null. Q means simple. Q is equal to NE. What is E? And number of total electrons here. In this is called density. Is the total electron volume is there. E null. So can be placed here. I is equal to total charge ENAL, E null, divided by T. In 1 second it will be given as a 1 second. So here can be taken as ANAL, E null, or in relaxation time further can be given as it's a E null. Now we have taken the drift velocity. What the velocity acquired by this? So suppose that with the Vd velocity electron is traveling this distance. So in place of, I'm telling, listen here guys, a short way just coming it is, okay. Suppose it's moving from left to right in V length. So length can be given as a velocity into time. Is that clear? And time can also be L by Vd this time. So current constituted in the time is Q by T. So I is equal to Q is whatever the T. This will be here L by Vd. The time is here L by Vd. What we can speak here? Q is what? It's a ENAL, E null, or it's a Vd by is L. And I is also L cancel. So it shall be E na Vd. This is a very important relation, E na Vd. Will remember you all guys. This is E na Vd. The current relationship between drift velocity E na Vd. E na means I. This all will be proportional for that. It's a Vd. Again, it's proportional to current. Is that? So these are the important relationship you will remember. Please have note down this expression for your understanding. Okay guys, tomorrow we'll solve some numericals with these illustrations. Thank you very much and have a nice day.